humans in finding, I think so, resources or information of their own domain. The main focus in recent year of this research work is to improve the semantics of our agriculture sciences, a sub-discipline or subdomains. In agriculture sciences, we are, I think, so well aware of agriculture sciences, and there are a lot of subdomains and the subfields. Okay, for example, uh, we can say, let's say, uh, agronomy, for example, biotechnology, food and nutrition sciences. All of them are subdiscipline or subdomains of agricultural sciences. Semantic is improved through ontology engineering of any domain. Amended and developed ontologies will be uploaded to existing standardized and approved biomedical repositories. And our main focus is to, I think so, develop our own overhead, develop our own W3C approved standard ontology repositories. There are a lot of repositories, ontologies repositories based upon your research area. For example, the dear professor before me presented in front of you something about nuclear engineering. So there are a lot of ontologies of nuclear engineering as well, W3C approved ontologies, and there are a lot of biomedical ontologies laboratory. Like for example, the famous one is Bioportal and online biomedical ontology. In the first phase of this research work, Agri-Ontology, food and plant ontology will be developed or improved. They are, I think so, still exist. There are a lot of ontologies. Agri-Ontology is over here. Different agri-ontologies and food ontologies and plant ontologies. Researchers are busy to improve it and to, I think so, make new and innovative ontologies. New ontologies of rare agri field is the principal focus of our proposed work. For example, there is I think so principally no ontology, well-known ontology for entomology, let's say, and there is a gene ontology, but there is no bioinformatics ontology at all. And itself for agri-informatics, there is no well-defined terminology or ontology. Okay, there is plant ontology, there is onto food ontologies. I have to share, I think so, the screenshot of famous ontology editor. The project has been, I think so, developed by Stanford University. The famous and well-known and extensively used ontology editor is Protage. Okay, and I have to share screens of Protage editors. Okay, and I have to show you some ontologies in this presentation, short presentations. Majority of agriculture researchers and over here in our country and also in other, I think so, developing countries, they are used to their own field terminologies or vocabularies, but they are, I think so, ignorant of using the web resources, the web, I think so, research resources and other resources. Why? Because the web don't have terminologies or vocabularies. There is no linked database. For ontology, we also use another term called as linked databases. Linked databases. They are, I think, so different from traditional relational databases. Okay. You can Google some, I think so, difficult words in these presentations. And I think so, it may help you people, I think so, to choose this area, specifically this area for your honor research, the master and I think so PhD students. The work effort is to improve the semantics of agriculture sciences specified area on World Wide Web. Okay, there are a lot of repositories, OBO repositories, and I think so the buy portal. Okay, they are very famous and they have very good browsers. I think so. You can also browse ontologies. You can see their nodes. Okay, uh, the ontologies I think so have such kind of shapes and protege editor. Okay, this is onto food ontology and it is already developed and researcher is already busy. Researchers are already busy to uh, develop it to include more nodes in this I think so ontology. Okay, this is a plant ontology, and over here in the food ontology, all terms, all specified terms have specific name. But over here in plant ontologies, each term is represented by a specific code. Okay, and this specific code represent a specific term related to plants. Okay, plant have a lot of terminology, a lot of I think so related words. So actually researchers adopt coding systems for these terms. Okay, if there are I think so limited terms for any specific ontology, then you can I think so use specific name. Okay, this I think so research for especially for developing countries, this area is an outcome based research. Okay, students, you can think so train students to be a freelancer. You can train the traditional web developer. Okay, to jump from relational databases to linked databases. To jump from a traditional web. Okay, web two to I think so more informative semantic web. Okay, and they can I think so learn how to develop a linked database or terminology or ontology of any specific area. Okay, and they can upload it, and there is a lot of online work in this area. Okay, all corporate organization, hospitals, and government organization all over the world, they are I think so busy in developing ontologies. Okay, terminologies for their specific work area. Okay, the main focus of the intended project is also to train and equip the student with relevant skills and expertise. For example, there are two kind of people associated in agri-informatics. The information technology students, you have to train them because they are, I think, so well aware of tools and technology. They are well aware of Protege. They are well aware of classes, individuals, and linked databases and relation databases. So you have just to tell them, or you have to train them in the agriculture sides terminologies. Okay, and the agri side students, the agriculture side students, they don't know about information technology. They don't know about Protege. They don't know about linked databases. They don't know about semantic web. So in this project, okay, we have a plan, a comprehensive plan to train both side students. This is an interdisciplinary area of research. Okay, and you may be, I think so, I have to give you a surprise that this work can be initiated in any university, and a lot of universities are already working on this area. Okay, in their specific domains. So whenever you want to try to hang in this I think so interesting area to develop the semantics of any field beside agri-informatics, then you have two sides of researchers in this interdisciplinary field of research. Over here we have the agriculture side researchers, and we have the IT side researchers. Okay, the IT side researcher need training. Okay, need based training. In the other side, they don't know the agriculture terminology, the biology terminology, the bioinformatics terminology. So you have to tell them those things. Okay. For example, you have to explain to IT researchers and computer science researchers the central dogma of molecular biology. What is molecular biology? What is plant? What is animal? What is the big difference? How many types of or group of plants and animals are there? Okay, and the agriculture scientists, they are not aware of web development, semantic webs. They don't know the difference between Web 2, traditional relation databases base, I think so, web, and also the linked databases web, the semantic web. So this is, I think so, very, very, I think so, needful actions, and this may require a lot of, I think so, resources as well, human resources and relevant experts. They are, I think, there is a scarcity, and there is an calamity of relevant experts. Even majority of, I think so, traditional web developer or information technology developer, they, I think so, don't know about vocabularies or ontologies. Okay. Machine readable, semantic or machine readable web with linked databases. I have to, I think so. Some people may be well aware of this area. I think so. Already they know about this area. Okay. And if someone don't know, then I have to explain it in a little bit words. Semantic web provide a common framework for data sharing and usability across the web. Okay. Uh, the web 2 or traditional web data, we call it as unstructured data. It is, I think so, we they are not connected, the terms are not connected, but in semantic web, all terms, they are connected, and through a terminology, and the terminology is developed in a linked database, a collection of technologies and standards that allow machine to understand the meaning, semantics of information on the web. For example, over here, the semantics of agri-informatics. Okay, so this field is, I think so, catching eye of researchers, and this field is used by almost all corporate organizations. Okay, on daily basis, researcher and common user are in touch with World Wide Web and check a lot of websites and portal for different purposes. But the information on these websites don't have a logical or meaningful connections. So ontology is a field where the terms where we actually link the terms through a linked database, and in linked database there are relationship. We call it as triples. Okay, we become an integral part. We are well aware of this fact. We cannot deny it that it is an integral part of our life. Everything depends on World Wide Web, developed by Tim Berners-Lee. The famous protocol, HTTP protocol, was first developed by Tim Berners-Lee its son in 1989. And after that, web is an integral part of our life. So for better searching, for better mining, and for better integration, the web need to be machine readable, or in simpler, in other words, we call it a semantic web. Okay, the machine readability is the only solution. Therefore, there has to be a way, a model to represent knowledge on web, and it should be accepted by all websites on World Wide Web. There is a need to have a uniform way of creating such statements. Okay, so ontology are vocabularies developed in RDF and OWL, uh, open web language, and even some ontologies are also developed in XML. Okay, I don't want to complicate my discussion anymore. This is, I think, so I want to uh, I want that students and researchers of other fields, they also understand my presentations. Okay, so what is the standard way of developing terminology in ontology? You should remember that it should be based on OWL and RDF framework. Okay. The relevant content should be linked with proper relationship among them. OWL and RDF are common framework for any data model in a linked database. Okay. The given plant ontology in the picture is, I think, so OWL ontology. Okay. And the editor was used, as I already mentioned it in the start of my presentation, Protage. And I praise Protage because Protage is extensively used and standardize. And you may be surprised that Protage have a lot of repositories and a lot of rich features. You can also exercise it for your own research purpose. Okay. Protege editor. In this project, we will stick in all standardized concept terminology and techniques issued by Stanford Protege product. Uh, it is also in combination with, I think, so one British university, okay, Manchester University and Stanford University. It is a combined project, okay, and freely open source, the Protege editor, the web-based, the I think so Unix, Linux-based, Windows-based, they are I think so free to be delivered and to be used. Okay, over here in our research center, we have expertise in proven skill to work fluently in Protege. Okay, it is quite good to develop ontology uh, in interdisciplinary research area. Okay, it is good, it is very interesting, but it is really hard and difficult. Okay, if you are experts in IT tools and technologies, okay, for example, Protege editor, and you are well aware of developing ontologies, but if you want to develop agri-ontology, for example, onto food ontology, so you have to acquire knowledge of nutrition sciences in food. Okay, the given the picture is onto food ontology. Okay, the famous ontology. We also working on the this ontology, and a lot of researchers are busy to make it more comprehensive to cover other aspect of food. Okay, uh, and this I think so. The term they are called as nodes or individuals. There are classes in individual, just like in traditional I think so object-oriented paradigm, or I think so a relation database paradigm. Linked databases have the same concept. There are classes, there are individual, and those classes and individual are interlinked with each other. Okay, the relationship I think so in object-oriented paradigm uh, is either inheritance or association, and in relation databases it is unary, binary, or ternary relationships. But over here in linked databases, you should remember that the only relationship between individual classes, subclasses, we call it is triple. Triple have subject, object, and predicate. Okay, predicate means the name of relationship. If any of audience is familiar with traditional relation database and also the binary relationship, okay, binary relationship type, then in binary relationship type there are two entity types, and those entity types are interlinked with a relationship, and each relationship have name and each relationship have an opposite relationship. In the same context, in linked databases, the individual or subclasses, they are connected with each other. For example, over here, any you can take any two, I think so, of nodes. They are interlinked with each other, and this relationship have name. The name of relationship over here in linked database is called as predicate. Okay, and there are obviously two entities involved. Okay, and the two entities and the predicate, they are called as triple. Okay, I have to further explain it in coming slides. This is a view of a simple ontology. Okay, the food ontology and protege editor. Okay, these are the classes and subclasses and individuals. Okay, there is I think so the classes are, I think so, apparently clear. This continuing, for example, look at this continuing, and then I think so the occurrent, they are the major classes. For example, inside the continuant, they are generally dependent continuant. Okay, and they are independent continuant. Okay, these are subclasses, specifically independent continuant. Okay, these are the subclasses of the major continuant class. Okay, and protege editor have its own structure query language. We call it as sparkle. You may be aware of this thing. Okay, if you don't know, then you can download it, and I think so the thing is very easy and interesting. Okay, not as easy as I say. You have to cover a lot of terms and terminology. Uh, Protege have view facilities as well. View can also be created in linked databases. View are building blocks of the Protege user interface. They can be placed in Protege anywhere on any tab. Okay. Property, for example, look at this. This is dietary habits and food names. Okay, and for example, this dietary habits have a relationship with abstract object. Abstract object is a superclass, and dietary habit is a subclass. And there may be, if you open this practically, there may be other individual inside the dietary habits. Okay, so the relationship between abstract object and dietary habits, or the individual of dietary habits and dietary, for example, the individual between uh, uh, in the dietary habits and dietary habits itself, we call this relationship is property. Okay, and there are two kind of property. One is object property and one is data property. Okay, for example, over here there is weight. Obviously, have a numerical value. Okay, so if an individual have a numerical value, then such kind of property is called as a data property. Okay, and the other I think so properties among, I think so, weight and abstract object, let's say, or abstract object and immaterial entity, let's say, or immaterial entity and independent, these properties are called as object properties. So any ontology, for example, I am giving you an example of food ontology or any other ontology. There are a lot of object properties, but the data property are very few in number. Okay, role and property restriction on slot or facet interfaces are role restrictions. Okay, this slide explain the properties. Okay, and also the triple. The right side, I think so, diagram clearly, I think so, explain the triple concept. The triple means in traditional relation databases we call it is binary relationship type. Over here at the left side, you can see clearly the object properties in unto food ontology. Okay, the left side, the leftmost. You have to further browse and you have to further, I think so, extend these object properties. Okay, an object property is between superclass subclass, individual of subclasses. Okay, and between the individual as well. Okay, if an individual or subclass, if they have a numerical value, okay, then in that case we call it as data property. Okay, right side, as this is, I think so, Protege 5.5. Okay, you can, I think so, download it free of cost. Okay, this diagram explains the triple concept. This diagram, the right side, they explain the triple concept: a subject, object, and predicate. For example, over here, apple, apple have type golden apple. Okay, and this is a triple between apple and golden apple. And this is subject, this is object, the apple is object, this one is subject, golden apple, and have type is a predicate. So a predicate, subject, and object is called a triple. Okay, okay, apple grow in Savat, for example, apple grow in, I think so, Beijing. Let's say you can name it Beijing. Let's say so apple is a subject, Beijing is a object, and grow in is a predicate. So we call it as a triple concept in simple words. These are the individuals. Individual golden apple, peach. I think so. Apple and the location names. You can use other location names for your city or your, I think so, province. Okay, it doesn't matter. Okay, Protege use unique name assumption for individual nomenclature during ontology development. In OWL, the similarity and difference between individual must be explicitly stated. Okay, between individual and individual come in the category of, over here, these are individual, they are of any super class, and they have other, again, super class. Okay, this is, the class browser over here. Okay, you can explore classes. Okay, and you have to explicitly tell the Protege editor the difference between individual. Okay, of some individual and some domain is under. Okay, over here, these are individual: golden apple, peach, and apple. Okay, these are individual, and they have a relationship, and the relationship is binary over here, just like, and traditional relation databases we call. But over here, you will never use the term binary relationship. You have to use a triple, and this triple have subject, object, and predicate. Okay, for example, over here, golden apple is a subject, and apple is a object, and have type is in a predicate. Okay, we can also call it as a predicate logic. Okay, uh, ontologies, if we develop it, they have a comparison and merging. I think so. Facility Protege also gave us a comparison and merging facility. For example, any new ontology, or if you improve existing ontology, okay, then Protege gave us, I think so, the facility to compare your own developed ontology in your own repository, or when you have no intention to deposit it in, or if you don't have, you cannot afford any research center, all research centers cannot afford repositories of their own. So you have to upload any ontology, any relevant ontology, I think so, to existence specific field ontology repository. So over here, obviously, if you develop onto food ontology or any food ontology, or if you develop, I think so, computer network ontology, or gene ontology, or wireless cooperative network ontology, then obviously you have to compare it with pre-existence ontology. This is the important part of any research. You have to compare your own work with previously developed or previous version of that research. Okay, so Protege have the facility to, I think so, compare ontology with pre-existence in any repository. Okay, it doesn't matter. You can download, I think so, in your desktop computer. You have to install Protege, and then you can download any OWL ontology from web. It doesn't matter. Okay, and then you can, I think so, if you finish working in any ontology, then you can, I think so, compare it with pre-existent or previous version of that ontology, or any similar ontology if that ontology not existed up to now. For example, if there is no entomology ontology, if there is no biotechnology ontology, then you have to compare it with nearmost. For example, biotechnology ontology can be compared with the bioinformatics ontology. Okay, so such kind of thing. There are recently and currently in Protege 555, there are three algorithms through which we compare ontology as shown in the figure below. I think so. My presentation can help relevant researchers, and they can follow this field and interesting field of research for their specific domain. If they don't want to improve the semantics of agri-informatics, then they can work in another field, in another subdomain. It really doesn't matter. Okay. Merging of ontology and protege. Merge facility is also available. For example, if I already show you in pictures the unto food ontology. If I have to develop another food ontology with same term, some term obviously may be different from existing ontology, and country-wise, food terminology is different. Okay, for example, there may be a slight difference of food terminology in mainland China, in Hong Kong, and in Taiwan or Thailand. Okay, so those terminology can be incorporated by local researchers. Okay, there may be a difference of terminology in plant protection, in seed protection. These are, the subfield of agriculture sciences. Okay, so obviously there is a need of merging of ontology. Okay, so merging facility is also available in Protege. Okay, ontology lookup services provide interactive and programming interface to query, browse, and navigate an ever-increasing number of biomedical ontology and control vocabulary. And this OLS is practically working in bioportal. Okay, okay. There are a lot of ontologies over there, and an OBO. Okay, since the deployment of OLS, the volume of data for querying increasing at a large scales. Okay, you can Google it. I can share this PPT presentation. You can verify it. Okay, my statements. You can challenge it. It really doesn't matter. Okay, the intention of cupboard system. There is another browsing facility and merging facility for ontology. We call it as a cupboard system. They are existing. They are working. Some are compatible with Protege either, and some are not. Okay, the picture below is of Protege editors. Okay, over here you have, POPO means plant ontology, and RO, these are other ontologies over here. You can merge ontology. You can merge your own ontology with pre-existing, that you already downloaded from any repository. It also provide a complete, the cupboard system also provide a complete friendly environment to find access in ontology. Uh, what is, I think so, the main contribution and integration of proposed work? Why I share these things with majority of agriculture researchers have weak command over the use of web resources. They even don't know the famous gene bank. They don't know how to use NCPI or EBI or any other biotechnology as agri-informatic sources. So how can we use it? Is due to improved vocabulary or terminology of ontology of, for example, their own field, their own agriculture sciences field, like, for example, animal husbandry, like, for example, food ontology, like food protection, plant protection, entomology, agronomy. These are the agriculture sciences fields. So they can better utilize the web resources if they are able, if we make them able to better utilize the web resources, then they, the overall research, their performance will be improved. Okay, and they may really understand and quickly understand that something is already existent. Okay, the main objective of semantic web like data interoperability and ontology reusability can only be ensured through a domain-specific library or repository. Specific and specialized training of bachelor and master students will be prime focus throughout the duration of this project. Okay. For example, uh, there are a lot of projects online. They are working, and we monitor the progress over here of those projects. So the fruit of this project, to students and to the society as well, is to train the bachelor and master students, okay, in developing ontology. So they may be, I think, so better equipped with even freelancing or any market relevant, I think, so job. And the if they develop a vast majority of ontology, then the terminology will be refined, it will be improved, we will be more and more, I think so, effective in the life of agriculture scientists. Acceptance of this potential project for funding will speed up these efforts. We will be able to incorporate more graduate researchers how to create agent for the integration of web data. This is the principal focus of semantic web. In our country, for example, over here, the literature ratio is very low and IT literacy is negligible. People are using the social data. Obviously, Weibo and Zhen Wang, I think so, Facebook, they are well aware of these, I think so, things, but they don't know about IT literacy. They even don't know about their own privacy, I think so. Okay, for example, agriculture is a main, I think so, field in any country, and it play a vital role in the economy. Okay, so if you, I think so, improve and refine the terminology, vocabulary, ontologies relevant to agriculture sciences, then it will be, I think so, good for humanity and also for the country economy. The use of web search resources among agriculture scientists community that will encourage its constructive use in their domain for specific for society and economy, as I right now stated it. Okay, the web, for example, in any country, the agriculture, I think so, the common farmer, they are using web in their own languages. For example, Mandarin or Urdu or, for example, French language or Korean language. They are ignorant of English language. This is another barrier. So this field have another gateway for local researcher. For example, researcher in China, they can work out the same agri-informatics vocabularies or ontologies in their, I think so, specific language, like simplified Chinese, Zhongwen. Okay, they can also develop it in Zhongwen or in I think so, Zhong Hanyu. I think so. We call it as Hanyu or Zhongwen. I am also graduated from Harbin Engineering University, Hakong Chung Tash. Okay, so for local researcher, this field, I think so, is most catching because beside agriculture resources, researchers, the the common farmer, they actually use the web, okay, in their local languages. So if you work out the terminology and vocabulary, okay, in local languages like simplified Chinese, then there will be a revolution, okay, revolution of informations, okay, and HTTP base. I think so. Any applications, okay, that can help the local farm, okay, and Protege have facility to develop and to amend, I think so, natural languages ontologies, and there are other specified editors for different countries, local or natural languages. Okay, we develop ontology using different kind of local languages. There is a boom of semantic sciences and ontology engineering job. Nearly all big corporate IT research firms are busy or tend to develop ontology and relevant domains. Expertise in ontology engineering help us in job protection. Ontology engineering has extensive freelancing opportunity. Economic boost is only possible if WIB is properly interpreted for non-IT researcher. As I gave you an example of farmer. Okay, and if you go beyond the